Welcome to my course about electrodynamics based on the Maxwell's equations. I'm pretty sure that in school you have already heard of the terms magnetic field, electric field, and maybe also the electromagnetic wave. And maybe you even have an understanding of what these terms mean. So here's an example. So when we have two charges, we can draw the electric field lines between these two charges. And when we have a wire with a current, then we can draw the magnetic field lines by using the right-hand rule. And if we consider light as an electromagnetic wave, we can see that the electric and the magnetic field oscillate in time and space. But the question in all of these three cases arises, why is that possible? And how is it possible? Why do the electric field lines look as they look, and why do the magnetic field lines look as is shown here? And the answer in all cases can be related to a theoretical concept that is based on four equations. So these equations have been formulated by Maxwell in the 19th century, and they allow to explain all of these terms above and even more. This course contains more than 9 hours of video lectures. It even includes a 2-hour mathematical tutorial at the very beginning to help you get started with the mathematics. Furthermore, it contains several multiple choice quizzes, so you can check if you really understood what I told you. The same purpose is served by these exercises that you can solve by yourself, and of course I will provide the solutions with a video. And you can also download all of my slides that I'm presenting in this course. My name is Berger and I'm a postdoctoral researcher who's been working in physics for more than 5 years. I have a lot of experience supervising bachelor students, master students, and even PhD students, mainly in quantum mechanics and electrodynamics. As I told you, we will start with an optional tutorial about the mathematics. So this will contain topics like the complex numbers and multidimensional calculus. So we will introduce the nabla operator and, for example, line integrals and surface integrals. Then we get started with the main topics. So here we will start with a discussion about early electromagnetism and light as an electromagnetic wave. So this introduction will be quite short, and you will see what was known to physicists before Maxwell formulated his equations. So then in the third section, the main part starts. Here I will introduce the Maxwell equations and I will motivate them by symmetry. Of course, we will discuss these equations in great detail because they are really the basis of this whole course. And then for the remainder, which will be the majority of this course, we will solve special cases and also come up with general solutions to these Maxwell's equations. So for example, we will consider again light as an electromagnetic wave in vacuum. So here you will really see how these solutions rely on the Maxwell's equations. And then we will discuss electrostatics and magnetostatics, where we have stationary charges or stationary currents. And based on these findings, we can come up with a general solution by using retarded potentials. You will see and learn all about this in the 7th section. And finally, I will conclude with the 8th section, which is quite short again. So this is where we will discover the electrodynamics in matter. For example, if you want to consider the electric field in a piece of metal and not in vacuum. And you will see that the equations look very similar, and therefore the physics is very similar to what we have learned. What I really like about theoretical electrodynamics is that we just have to discuss the 4 basic Maxwell equations, and from them we can extract all of the knowledge that was known before, and we can even discuss most of the modern phenomena of electrodynamics. So I hope to see you in the course soon.